In the early spring of 1991, American commercial aviation was entering what many considered its safest era. The lessons of previous decades, improved crew resource management, advanced weather radar systems, better aircraft design, had made flying statistically safer than driving. Airlines like United, one of the largest carriers in the United States, operated thousands of flights daily with remarkable efficiency and safety records. March 3, 1991 began like any other day at Denver's Stapleton International Airport. Stapleton, which would later be replaced by Denver International Airport in 1995, was a bustling hub serving as a critical connection point for travelers across the American West.
Thank you for waiting, ladies and gentlemen. We've invited first class. Now we're inviting executive platinum, emerald, sapphire, and ruby. If those words are written on your boarding card, please come forward for boarding. Also, I'd like to invite group number 1. Please, ladies and gentlemen, have your boarding cards out.
Colorado Springs Municipal Airport. The flight distance was barely 70 miles, a journey that would take approximately 40 minutes gate to gate under normal conditions.
Group 1 is now boarding. And now I'd like to invite group 2, rows 27 through 32, boarding groups 1 and 2 in first class.
Yet this particular flight would become anything but unremarkable. It would spark one of the most intensive investigations in the history of the National Transportation Safety Board, challenge fundamental assumptions about aircraft design, and ultimately expose a potentially catastrophic flaw hidden within one of the world's most popular aircraft models. The aircraft assigned to Flight 585 was a Boeing 737-291, registered as N999UA. To understand what would later unfold, we need to understand this aircraft and its place in aviation history. The Boeing 737 family is the best-selling commercial jetliner series ever produced. First introduced in 1968, the 737 was designed as a short to medium-range twin-engine, narrow-body jet, perfect for regional routes and smaller airports. By 1991, the 737 had already proven itself as a workhorse of the airline industry. Reliable, economical, and versatile. The specific variant operating as Flight 585 was a 737-200, part of the original generation of 737s. Approximately 23 years old at the time of the accident. While this might sound old by consumer standards, our commercial aircraft are built to last decades with proper maintenance. Age alone was not unusual.
Turn right at 180 and maintain at 3000.
N999UA was powered by two Pratt & Whitney JT 8D turbofan engines, the standard power plant for the 737-200 series. These engines were proven, reliable, and well understood by maintenance crews and pilots alike. The aircraft had undergone its required maintenance checks and inspections. There were no outstanding mechanical discrepancies.
Just about ready to depart. We should be away on schedule in the next couple of minutes or so.
N999UA was airworthy and fit for service. The 737-200 had a seating capacity that varied by airline configuration, but United's version typically seated around 115 passengers in a mixed-class arrangement. On this particular morning, the load would be light.
This is the captain speaking.
Combined with the 5 crew members, only 25 souls would be aboard. The aircraft's systems, hydraulics, flight controls, electrical systems, avionics, had all been functioning normally on previous flights.
Final approach checklist. Flap set 30. 30 set. Gear down. 3
Nothing to suggest that this aircraft posed any greater risk than the thousands of other 737s flying worldwide on that same day. One of the most important factors investigators examine after any aviation accident is crew qualification and performance. Captain Harold Green occupied the left seat as pilot in command. Captain Green was 52 years old and brought an extraordinary level of experience to the cockpit. His logbook showed over 33,000 total flight hours, a figure that placed him among the most experienced airline captains in the United States. To put this in perspective, U.S. airline regulations at the time required only 1,500 hours.
9 hours and 40 minutes will eventually reach a cruising altitude of 35.
Also, I'd like to invite group number 1. Please, ladies and gentlemen, have your boarding cards out and available. Group 1 is now boarding. And now I'd like to invite Crew 2, rows 20.
This meant he had extensive type-specific experience with the aircraft's handling characteristics, systems, and quirks. He had flown in and out of Colorado Springs numerous times. He was familiar with the local weather patterns. Or lack of experience. Captain Green's training records, check ride results, and performance evaluations were all reviewed post-accident. Every indicator pointed to a competent professional aviator who took his responsibilities seriously. There were no red flags in his medical records, no history of incidents or violations, no evidence of substance abuse or personal problems that might have affected his performance. First Officer Patricia Eidson sat in the right seat. First Officer Eidson, 42 years old, was also an experienced pilot, though with fewer hours than the captain, a normal situation in airline operations where first officers typically accumulate hours while working toward upgrading to captain. Her total flight time was approximately 8,000 hours, as with substantial time in the 737 as well. First Officer Eidson's role on this flight was as the pilot flying, PF, meaning she would handle the actual control inputs during the approach and landing.
All available officers report to column base.
We'll do our best to give you a smooth flight over turbulence is always a possibility, and for that reason, it's company policy to recommend.
This division of duties is standard practice in commercial aviation and is designed to distribute workload and enhance safety through cross-checking. The partnership between Green and Eidson represented a well-balanced crew. Their experience levels complemented each other, and both were current and qualified for the flight.
Turn left at 90. Maintain 4,800 to establish an approach.
Derived from the cockpit voice recorder, showed normal crew resource management practices. They were communicating clearly, making appropriate callouts, and following standard procedures. The cabin crew consisted of 3 flight attendants, all trained and qualified according to Federal Aviation Administration requirements. Their role would be limited during the short flight, mainly preparing the cabin for landing and ensuring passenger safety and comfort. There was nothing unusual reported about the cabin crew's performance or the passenger cabin environment that morning. Understanding the route and the environment is crucial to understanding what happened to Flight 585. Denver and Colorado Springs are both located in Colorado's Front Range region, where the Great Plains meet the Rocky Mountains. This geographical position creates unique and sometimes challenging weather conditions that pilots must respect and understand. And Denver's Stapleton International Airport sat at an elevation of approximately 5,333 feet above sea level. Colorado Springs Municipal Airport was even higher, at about 6,187 feet. These are significant elevations. Many major airports around the world sit near sea level. The high-altitude environment affects aircraft performance, requiring longer takeoff rolls and careful attention to density-altitude calculations. The flight distance between the two airports is only about 70 miles as the crow flies, slightly longer when following published airways and approach procedures. Under normal conditions, the flight would climb to perhaps 10,000 to 13,000 feet for the cruise portion, then begin descent approximately halfway through the flight. It was the mountains themselves and the weather phenomena they created. The Rocky Mountains generate complex weather patterns. When prevailing westerly winds blow across the mountain peaks, they create what meteorologists call mountain wave activity and rotor turbulence. These are areas of severe up and down drafts, wind shear, and turbulence that can exist even on clear days with good visibility. Or cloud formations. Pilots flying in mountainous regions are trained to recognize the signs of mountain wave activity: lenticular clouds, lens-shaped clouds that form in the wave crests, unusual wind velocities and directions, and turbulence reports from other aircraft. At 9:41 a.m. Mountain Standard Time, United Airlines Flight 585 was approximately 15 miles southeast of Colorado Springs Municipal Airport, cruising at 10,000 feet. The Colorado landscape spread below, the city nestled against the foothills. Inside the cockpit, Captain Harold Green and First Officer Patricia Eidson were fully engaged in the approach phase of flight. This is one of the most critical periods in any flight. The transition from cruise to landing requires precise coordination, multiple configuration changes, constant communication with air traffic control.
Maintain your altitude of 15,000 feet.
First Officer Eidson, as pilot flying, had her hands on the controls. Captain Green, as pilot monitoring, and was managing the radios, monitoring instruments, and providing backup oversight. This crew coordination was textbook, exactly how airline operations are designed to function. The Colorado Springs approach controller's voice came through their headsets, calm and professional. United 585, descend and maintain 7,000 feet. First Officer Eidson smoothly reduced thrust and initiated the descent. Captain Green acknowledged the clearance. United 585, out of 10,000 for 7,000. Aviation is drilled into pilots from their earliest training. It confirms the crew heard the instruction correctly and are complying. The Boeing 737 began its descent, the nose pitching down slightly as Eidson adjusted the pitch trim. That the engines spooled back to a lower power setting, and the aircraft began losing altitude at approximately 1,500 to 2,000 feet per minute, a normal descent rate for this phase of flight. As they descended through 9,000 feet, then 8,000 feet, the crew continued their approach preparations. They reviewed the approach plate, the published procedure for landing on runway 35. They noted the minimum descent altitudes, the missed approach procedure, what to do if they couldn't land, and the runway configuration. The wind information was updated by the controller. Winds were from 320 degrees at 25 knots, gusting to 35 knots. The wind wasn't aligned straight down the runway, but coming from the northwest at an angle. Experienced pilots handle crosswinds routinely, on using a combination of bank angle and rudder input to maintain runway alignment while compensating for the wind pushing the aircraft sideways. Captain Green and First Officer Eidson discussed the wind conditions briefly. Their conversation, captured on the cockpit voice recorder, was professional and matter of fact. These were exactly the kind of winds they had expected based on the earlier weather briefings. There was no alarm in their voices, no hesitation. They had both flown in similar conditions many times before. As Flight 585 descended through 7,000 feet and leveled off temporarily, the crew began extending the flaps.
Flaps set. Continue descent.
Allowing the aircraft to fly more slowly without stalling. This is a critical part of landing configuration. Their First Officer Eidson called for flaps, and Captain Green moved the flap lever to the appropriate position. The flaps extended smoothly, 1 degree, then 5 degrees. The aircraft's speed decreased accordingly, from cruise speed down toward approach speed. Everything was responding normally. The landing gear was still retracted at this point. Standard procedure. The gear would be extended later, closer to the runway, to minimize drag and fuel consumption during the approach. Headings to fly that would position the aircraft for the final approach to runway 35. United 585, turn left heading 350, maintain 7,000 until established on the localizer, cleared ILS runway 35 approach. This clearance authorized the crew to intercept the Instrument Landing System, ILS, for runway 35. The ILS provides electronic guidance, a vertical beam, glide slope, showing the correct descent path, and a horizontal beam, localizer, showing the runway centerline. Pilots use these signals to fly a precise approach even in poor visibility, though on this clear day they could see the airport visually as well. Captain Green read back the clearance perfectly, confirming they understood and would comply. First Officer Eidson turned the aircraft to the assigned heading, 350 degrees, almost due north, aligned with the runway. The flight was now approximately 8 miles from the runway threshold, descending through the Colorado air at about 180 knots, roughly 207 miles per hour. Inside the cabin, the 20 passengers were likely reading, looking out the windows at the approaching city, safety checks, and taken their seats for landing. No one had any indication that anything was wrong. The engines were running smoothly, all instruments showed normal readings, the flight controls were responding properly to inputs, and the crew was executing the approach with professional precision. At 9:43 a.m., United Flight 585 was established on the final approach course to runway 35. The aircraft had captured the ILS signals and was tracking the electronic glide slope down toward the runway, approximately 4 miles ahead, extending them further to increase lift and allow even slower flight speeds for landing. Captain Green extended the flaps to 15 degrees, then called for the landing gear. The landing gear extended with the characteristic rumble and thump that passengers often notice on approach. 3 green lights illuminated on the instrument panel, confirming all 3 landing gear, nose gear, and 2 main gear were down and locked. This is a critical safety check. No commercial pilot would attempt a landing without positive confirmation that the gear was down and locked. The aircraft was now in full landing configuration. Flaps extended, gear down, speed reduced to final approach speed of approximately 140 knots. The runway was clearly visible ahead through the windscreen, growing larger as they descended. The approach controller handed them off to the tower controller. United 585, contact tower 118.4. Captain Green switched radio frequencies and checked in. At precisely 9:43 and 24 seconds, AM Mountain Standard Time, something went catastrophically wrong. Without any warning, no alarm, no unusual sound, no preceding indication of any kind, the Boeing 737 suddenly rolled hard to the right. The movement was violent and immediate. The right wing dropped sharply. The aircraft's bank angle increased rapidly, 20 degrees right, 30 degrees, 40 degrees, in a matter of seconds. The bank angle steepened further, 50 degrees, 60 degrees. The right wing was now pointing almost straight down toward the earth. A descending, accelerating turn that becomes harder and harder to recover from as it develops. For 4 seconds, from the moment the uncommanded roll began to the moment of impact, a public park area located approximately 3.5 miles south of Colorado Springs Municipal Airport. The same was true for the crew of US Air 427. Their last moments, fighting controls that were working against them rather than for them, would have been terrifying. But they had done everything they possibly could have done. To fully understand what happened, let's walk through the specific failure sequence that investigators believe occurred in both accidents. The servo valve contains a slide assembly with 2 closely fitted parts, the main slide and the bore it moves within. Under normal conditions, there's a precise gap between these components, approximately 0.002 inches, or about the thickness of 2 sheets of paper. This gap is filled with hydraulic fluid that both lubricates the slide and provides the precise control needed for smooth rudder movement. The components are made of steel and aluminum alloys, materials chosen for their strength and lightweight. But these different materials have different thermal expansion characteristics. When temperature changes, they expand and contract at different rates. The slide, being more massive and not in direct contact with the warm fluid, remains cold longer. This differential thermal expansion can temporarily close the small gap between the slide and bore. If the pilot commands a rudder input at this specific moment, this is what investigators concluded happened to United Airlines Flight 585 on March 3, 1991, and to US Air Flight 427 on September 8th. It was 1994. 25 people died in the first crash, 132 in the second, 157 lives lost to a failure mode so subtle and rare that it took years and the loss of 2 aircraft to even identify it. On March 24, 1999, more than 8 years after the United 585 crash and nearly 5 years after US Air 427, the National Transportation Safety Board issued updated final reports for both accidents. For United Airlines Flight 585, the NTSB amended its original undetermined finding. The new probable cause statement read, "The loss of control of the airplane resulting from the movement of the rudder surface to its blowdown limit. The rudder surface most likely deflected in a direction opposite to that commanded by the pilots as a result of a jam of the main rudder power control unit, servo valve secondary slide to the servo valve housing offset from its neutral position, and over travel of the primary slide." For US Air Flight 427, the probable cause was determined to be the same mechanism. After the most intensive investigation in NTSB history, after thousands of hours of testing and analysis, After examining possibilities and pursuing leads down to the smallest detail, the truth was finally known. The Boeing 737, one of the most successful and widely operated aircraft in history, had a subtle but potentially catastrophic flaw in its rudder control system. Under rare but possible conditions, the system could reverse pilot inputs, causing an uncommanded full rudder deflection that was essentially unrecoverable at low altitude. The next question was obvious. What would be done to ensure this never happened again?